right, so I've just been doing a bit of extra work or a bit of tweaking of this four-cylinder LCH installation, which has been going really well, I must say. But there was one area that I've been experimenting with, and that's with this pump here. Now, what we do is we use these Bosch pumps. They're fantastic, but they're an automotive pump, and they have some smarts in them, which I'm not particularly, over the moon about, because there is a possibility that if the water gets low, the pump can stop. Well, maybe not stop while it's once in operation, but it certainly won't start. And we have found, and some customers have also found, that it can be challenging to get all the air out of the systems, and then the pump will eventually fire up. Now, I find that a little bit potentially problematic for obvious reasons. We never want this pump, one, not to start, and two, to stop because of low water level. In an aircraft application, if you're running out of water, the last thing you want is the pump to stop completely. So even though these pumps have been working really well and we've had very little problems with them, what I've done recently is I have modified this pump so that as soon as you hook 12 volts up to it, it starts up. And I've also added a second plug there for a potentiometer to control the speed. Now, the way I've done these pumps are still the same. The difference is I've taken the electronics in this one, the microprocessor in this one is been programmed by the manufacturer to have this low water level and low water level sensing, and also load sensing, I guess, is how it detects it. It sort of pulses. And when you don't have the pulse modulation wire connected, it will just run flat out, but it still goes through a smart process. Now, the way I've built this pump, it still has a microprocessor, an Arduino Nano, or potted into the back here, and also a 30 amp ESC, because it is a brushless motor. And this is now still a smart pump, but it's also acting as a dumb pump. In other words, as soon as you hook the wires up, it will run regardless of water. If you just hook this up to your 12 volt main bus, it will just fire up and it won't care about water. This one will. This one won't run without water present. I don't know whether it detects the load on the impeller or it actually senses the water in it. I'm not sure. I think it might be the load on the impeller, like a washing machine. But anyway, this one will fire up just as soon as you turn the pump on. It still goes through a sequence, but it'll always run regardless of whether there's water or not. So I think that's ideal. And here, if you add the potentiometer to it, you can control the impeller speed. And it's been programmed, the Nano has been programmed so that at the absolute minimum, it'll run at 25% and the maximum is 100%. And if you have a disconnection or a short of the pot, it goes straight to 100%. So as it is right now, if you hook 12 volts up to that, it'll just go to 100%. And as this one too will as well, unless you have the pulse modulation wire connected. Now here, all you need to do is connect a pot. It's just a simple, regular brush pot. And away you go. So here it is installed, and I'm very happy with it. It works really well. So here it is installed. I've got my 12 volt wires there, and I've got my pot connected to an insulated, what would you call a shielded wire, 3-core wire, and it's just simply going to a regular pot, 10K pot. And there it is there on the panel. And so I've made a little water flow placard, percentage water flow, a nice, volume knob, and there you go. So the way it works is, once you turn your master on, everything fires up, and away you go. So the first thing it does is it runs flat out, and as soon as it detects, and it has a pause, and then as soon as it detects the pot, it moves to the potentiometer. You can hear it there. And it won't switch off. You can't have the pot too low. It can't go below 20%. So I'll switch it off. And like a model aeroplane electric motor, you'll hear the windings beeping as it goes through its start cycle. Have a listen. and then you hear it drop down onto the pot. So as you're flying along, you can be monitoring your water temperature there, and if it's a really cold day, you can slow the pump down and you can let the engine warm up a bit. You can regulate the water temperature with this pot. Anyway, we'll see how that goes. I think it's going to be really good.